when they mention about this symbol with 50 kilo ohm, what it means is the resistance can vary between 0 to 50 kilo ohm. Okay, so you can take this as 0. So for the range of voltages between P and Q, so if you want to find this voltage, so remember the formula for potential divider, let's call this as V out. So your V out will be equals to your variable resistor over your variable resistor plus 10 times your input PD, which is 9. So that's a formula. So you substitute your RV as 0, what is your V out? Then you substitute your RV as 50, you find your V out. So when this RV is 0, you substitute then into the equation, your V out is 0. Then when you substitute 50, then you get V out as 7.5. So answer is B. Okay. Now, which one can be used as a potential divider? So the idea is very simple. If you mean by potential divider means if I adjust the variable resistor, the rheostat here, the PD across the lamp must change. That's what potential divider are. But in A, right, you see the lamp and the variable resistor, both of them connected in parallel to your cell. So whatever resistance you change this, your lamp will still follow the PD of the cell. So that means it's not a potential divider. Now for the part B, it looks like a potential divider, but it's not. You know why? When the current comes out from the positive terminal, when it reaches this junction, then it realizes to come to here, there are two paths. One here and the other one here. But this side has no resistance. This side has resistance. So what will happen is, it will bypass this. The whole thing will just pass through this and come out. So it means this won't be used at all. So in other words, the lamp will have the same PD as your cell. So also cannot be a potential divider. Because whatever resistance you change here, it doesn't matter because current won't be flowing. Now C, now this is different because the current will come out to here, halfway up to here, let's say, and then it will split. Correct or not? How much the current splits depends on the ratio of this side, the resistance, and this resistance of the lamp. So if you were to push the slider to a higher point here, let's say, so then you can imagine that this side has higher resistance, so you will get less current. This side less current, so this will get more current, so there will be higher PD. But if you were to push the slider to here, somewhere here, so then this side will be smaller resistance, so when current comes here, more current will pass through here, less current will flow through your lamp. So the PD across your lamp can vary. You understand? So if you can't imagine, I can draw for you again. So you take the first part before the slider, the first part before the slider as a resistor. Then the second part after the slider, so this is like after the slider, you take as another resistor. And then you connect a lamp. So it's something like this. Okay, so this is your circuit. You understand? So when you move the slider back and forth, you're changing these two resistances. So when you change the two resistances, then the current flowing through here and here will be different. You understand? Okay, so this can act as a potential divider. Whereas D also cannot, because your lamp once again is connected in parallel to your cell. So it follows the PD of your cell. Do you understand? Okay, so the answer is C. So first, you need to see which one has a greater PD. Now, the 1.5 volts cell here, that means the voltage should be divided between these two. This 1.5 also be divided between these two. Now, you notice that this 3 is the same, but the 0.5 and 2 is different. So let's look at this circuit first. How will the 1.5 volt cell, the voltage here be divided between these two? So this will take much more than this. Why? Because this is much bigger PD than this. But if you compare for this circuit, 1.5 volts divided by these two, but these two, the difference is not as big as these two, right? So this one will carry a larger PD than this, but it will be smaller than this. Because you see, the 1.5 volt divided, this one will take most of the 1.5. Whereas the 1.5 divided between these two, this will take more, but not most of it. So this PD is still bigger than this PD. So therefore, you can say that the answer is either A or B lah. Now what about power dissipated? Now power dissipated, you can use the formula for power dissipated. Now which formula do you want to use? Now you remember you have three formulas: P equals to VI, P equals to V squared over R, and P equals to I squared R. Now to compare between the two, what can we use? I would suggest we use P equals to V squared over R. Why? Because we already know that this PD is higher than this PD. Correct or not? And we know these two is the same resistance. So we're comparing these two. Resistance is the same. Who has a larger PD, X or Y? X. So X will have higher power dissipated. So answer is B. So the answer is B. So for this question, they are talking about what do you call it, reducing the value of the variable resistor. So what happens to the voltmeter and ammeter? Now let's talk about the ammeter first. The ammeter measures the total circuit current, right? So when you reduce this resistance, what happens to the total circuit resistance? Decrease. So total circuit resistance decreases, total circuit current must increase. So the answer is either C or D lah. What about voltage? Now the voltage of the cell will be divided between these two. If you reduce this resistance, this will carry less PD, so this must carry more PD. The answer is donkey, D. Very good. So if you want to show that the resistance of the resistor is 7008, so don't forget the voltmeter reading, which is, let's say, your V out, is equals to resistance of R over R plus RT, which is resistance of the thermistor, times 1.5. So since they already told you the voltmeter reading is 1, and they also mentioned to you that the resistance R you're supposed to find. So the resistance of the thermistor at 0 degrees, you check your information, it is 3900 ohm. Then you will be able to get your R. But you notice that this way is quite tedious, because you have to bring your R, cross multiply, and then solve and all that. So the easier way, I teach you, if they said that this is 1 volts, so wouldn't this side be 0.5 volts? So you actually solve from the other side. So you will assume that the PD across the thermistor is 0.5 volts. So you'll be 0.5 over the resistance of the thermistor, which is how much? They already gave you actually. So the resistance of the thermistor is 3009 over 3009 plus R times 1.5. You'll get the same answer, but it's easier to solve because your R is only on one side. I mean, there's only one expression for R instead of two. Okay, so you can use both ways. You should get your RS 7800 ohm. So the next part, if they ask you to find the reading on the voltmeter at 30 degrees, so what do? We actually refer that your resistance of the thermistor is now 1250. Alright, so I solve it a bit on top here because bottom no space. So the voltmeter reading is equals to the resistance of R, which you already figure out as 7008. So over 7008 plus the resistance of the thermistor at 30 degrees, which is 1250. Then you multiply by the EMF of the cell, and you should get your answer. Because now, remember, we are actually calculating this voltmeter reading, which is this PD. So you want to find this PD, you take this resistance over the total times 1.5. So take 7008 over the total times 1.5. So what they mention in the next part is that you replace the voltmeter with one having a resistance of 7008, because initially you assume that the voltmeter has infinite resistance, but now the voltmeter has a resistance of 7800 ohm. Now remember, we also calculated the R just now as 7800 ohm. So we know that these two values of resistors now. And we also know that they want you to find the reading of voltmeter for temperature of 0. So that means the resistance of the thermistor is 3900. Now, to find the reading on the voltmeter, I mentioned before, it's the same as asking you for the PD across the voltmeter. Do you understand? So if you treat the voltmeter as a resistor, so 7008 and 7008 in parallel gives you what? 3009, half of it. So you can redraw the circuit. So this will be like 3900 ohm. These two of them can combine to get another 3900 ohm. So how do you think the voltage will divide now? You notice that both have the same. So how would the voltage divide? Equally, right now. So in other words, this will be 0.75 volts, which also will be the PD across the voltmeter and also the R. So the reading of the voltmeter will be 0.75 volts. Okay, so this will be 0.75 volts. So to solve this question, you look at where the slider can move. So the slider can move to here and here. Now, if the slider moves all the way to here, will there be any resistance? No. So what will the PD? 0. But it moves all the way to here. That means it's going to measure across this 20 ohm. And 20 ohm, and this is also 20 ohm. So the voltage here will be split half-half. So this will take 6 volts. So that means it will be 0 to 6. Answer is A. So in order to get the expression, first you find the PD across P, which is I times P. That's the first equation. Then you find the total voltage, which is E, which is I, then P plus Q. Then you take equation 1 over equation 2. So V over E, the I will cancel. So the I here both will cancel. So you get P over P plus Q. So therefore V equals to P over P plus Q times the E. So the next part asks you, if you're given your circuit, and then you know these two resistances, alright, and they give you, what else? There's a thermistor here, and the voltmeter has infinite resistance. State and explain qualitatively the change in the voltmeter reading as the temperature of the thermistor is raised up. Now, what I need you to do is maybe redraw the circuit so it's easier to imagine. So remember, this is a 6 volts battery connected to 2000 ohm. Now, can you see that the 5000 and the thermistor can be found as a total parallel resistance? Okay, and the voltmeter, because it has infinite resistance, we leave it there. Now, very important now, when they say voltmeter has infinite resistance, what are they trying to tell you? If the voltmeter has infinite resistance, then no current will flow through your voltmeter. That means the current will come from a positive and it will not split. Because this has infinite resistance, then all the current will go through here. It will not go through your voltmeter. So you don't have to find the resistance in parallel, you just have to take this as a load. So then only it will split to 2. So the current will come here and then it will split to 2. That's why I'm taking these two to be parallel. So let's understand this. When the temperature of the thermistor increases, what happens to its resistance? The resistance will decrease, right? If the resistance of the thermistor decreases, what happens to the total resistance here? Decrease or increase? Decrease. So if this resistance decreases, then what happens to the voltage across here? Increase. Because when this side has lower resistance, it will carry less PD. So automatically this side will carry more PD. Because of 6 volts has to be divided between the two. Okay? So you say this, when the temperature of the thermistor increases, its resistance decreases. Its resistance decreases. Therefore, the total resistance in parallel decreases. Therefore, the total resistance in parallel decreases. Then you continue, you say the PD across the 2000 ohm resistor increases. The PD across the 2000 ohm resistor increases. So the voltmeter reading increases. Right? So the voltmeter reading increases. So firstly, the next part, when they ask you for the resistance of the thermistor at 19 degrees, what you need to understand, the voltmeter shows you 3.6 volts. That means the PD across this is 3.6 volts. So what you need to do is take this as 3.6 volts across here and find the total resistance in parallel. That means you use this circuit, because there's a potential divider, these two are in series, because you can only use a formula for series. So these two are in series. Find RP first, because you know this voltage is 3.6 volts, this is 2000 ohm, find RP. So the formula will be 3.6 volts equals to 2000 over 2000 plus RP times 6 volts, and then you will get your RP, which is how much? 1333, 133, okay, let's say. So then you use a formula for resistance in parallel, because this RP, which is this resistance, is between these two. So you can use back our formula for resistance in parallel, which is 1 over 1333.33 equals to 1 over 5000 plus 1 over R of your thermistor. Then you find the resistance of the thermistor. So you get R as 1818 ohm. Okay? Now this question is actually a trick question on potential divider. Now whenever we move the slider from X to Y, what happens? Now let's say we move the slider all the way to X. So we move the slider all the way to X. So that means the voltmeter will be connected in parallel to the cell. So it will be 4 volts, right? Now? So at X is definitely 4 volts. So it could be either A or B or D lah. But once you move the slider to Y, it is something like this circuit. Okay, so when you move the slider to here, it looks like this, correct? Now, they did tell me that the voltmeter has very high resistance. So when the current reaches this junction, it's supposed to split, but because the voltmeter has very high resistance, can current flow or not? No. So in other words, the current is only flowing here. If the current is flowing here, and that means there's no current here, will there be any PD or not? Because remember, PD is IR, so then there's no current, there is no PD here. So when they say no PD, that means there's no difference in potential between these 2 points. So in other words, the voltmeter which is measuring here, these two, so voltmeters supposed to measure this potential, which is the same as this potential, and since there's no PD, it's also the same as this potential. So it means this side will measure this side by the voltmeter, and the other side this side. So that means from here to here, so it's still measuring 4 volts, because there's no current through here. Because I just repeat, because there's no current here, so in other words, there's no PD. So I'll give you an example, maybe you understand. So let's say this is 4 volts here, and this is 0 volts. So this point is 4 volts, right now. But since there's no current through this resistor, there's no PD. There's no PD means the potential here is also 4 volts. So that means this side, the voltmeter reads 4 volts, the potential out. And on this side, it connects to here, which is 0 volts. So what the voltmeter will show you? 4 volts.